Good evening, everyone. I'd like to welcome you all to the Zeitgroß Planetarium in your own homes. We're going to have another Starry Night tonight. This is our English program, and we are thrilled to have you with us here this evening. Of course, we wish we could have you here in-house, and hopefully that will come soon. But in the meantime, we're grateful that we're able to come to you in your homes. So this evening, we're going to look at the starry sky from Berlin and see what we can see from our own backyards. And then from there, we will venture out into our solar system with some of the spacecraft that have explored before us. So with that, we're going to go ahead and get right into it. Starting off with a sunset. And sunset was at 5 p.m. tonight. Our days are getting longer and longer. And once the sun sets, we head into civil twilight, which doesn't make much of a difference in what you can see. And then we head into nautical twilight, which is about right now. So called because sailors were able to still see the horizon and position themselves with their classical instruments that they used. And then we end up at astronomical twilight. And once astronomical twilight ends, we're able to see all of the stars and planets out in our sky. Now, of course, in Berlin, we have light pollution. And so the number of stars that we see are a lot lower than what you see here. We see maybe 200 stars here in Berlin, and that's how it is in most major cities. But if you were to go out to a nature park or a star park, as in Brandenburg, for example, then you would be able to see a lot more stars. Now, shortly after astronomical twilight, we're going to make our trees go away to make it a little easier to see. Low to the horizon, we have Neptune. Now, Neptune can be briefly seen from about 7 to 7:30 p.m. in the south-southwest, however, only with binoculars. So if you have a pair of binoculars, it may be worth trying to check that out. Neptune, of course, we all like here because it was discovered in Berlin. We're going to go a little later into the evening now. To about 10 p.m. and take a look over to the west, because we're going to be able to see a couple more planets. So the first of which, we're going to take a look at Uranus. That is another one where you're going to have a telescope to see it, but it is out. So if you have access to a telescope and you have a clear sky, that's another one that's worth looking for. And it is best seen from about 7 p.m. to midnight. And this will go for the next couple days. I know it's snowing right now in Berlin, so we don't really have the clear sky outside, but over the next few days, if you have the chance to have a clear sky, that's something you can look for with a telescope. Now, you don't have to have a telescope to see all of the planets. We also have Mars that we can look at this evening out in the western sky. And it's going to be poorly visible during that civil twilight period. It'll already be out. But the best time to observe is from about 5:30 p.m. until 1 o'clock in the morning. It sets at about 1:30. And Mars will be easy to spot in the sky because it will be fairly bright. It won't be twinkling, and it will be reddish in color. We're going to look further south now so that we can take a look at our winter constellations. And I think our wintertime sky is one of the most beloved seasons to look at the sky. I know that a lot of people really like looking for one constellation in particular, and that is, of course, Orion the Hunter. Orion the Hunter is a rectangle, 2 stars at the top making his shoulders, 2 stars at the bottom for his feet, and then a row of 3 stars diagonally through the middle as his belt. Now, Orion's going to be our guide to the wintertime sky. And we're going to start by looking for his faithful canine companions. No hunter is complete without his dogs. And so the first thing that we can do with Orion is follow those belt stars the way they're pointing down. And we're going to follow them all the way to that seriously bright star that we see there, because that is Sirius, the dog star. As you can see, that's part of Canis Major's nose. And if you're thinking Sirius, Sirius Black from Harry Potter, you're on the right track. So J.K. Rowling took a lot of the names for the full-blooded wizards, particularly from the House of Black, and used stars and constellations to give them their names. And so Sirius Black came from Sirius the dog star. That's also why he turns into a dog. Now, if you've seen other Starry Nights, you know that when I've mentioned that something was major, there is always also something minor. And so nearby, we have Canis Minor, the little dog. And as you can see, as he comes out, people had really good imaginations because he is just 2 stars. For me, I think he looks a little more like a hot dog than a real dog, but that does make him a little easier to find in the sky. We're going to look the other direction now for Taurus the bull. To find Taurus, you can follow Orion's belt star straight up to the orange star in his eye, that is Aldebaran. There's a V making his face out to the horns, and then if you go back towards his shoulder, you are going to see M45, or the Pleiades star cluster. And we're circling that for you right now, so make it a little easier to see. The Pleiades star cluster has such an importance in different cultures around the world. There are more than 50 different references and myths to this particular star cluster from all over the world, all different countries, cultures, throughout time. So there are references in several major religious texts, including those from Judaism, Christianity, and Islam. We also see a lot of stories coming from the legends of the indigenous people of the Americas. So it's common to hear that the stars are 7 young girls or 7 young boys, and many of the stories also explain why the 7th star is more difficult to see. So when we look at the Pleiades outside of Berlin, where it's a little easier to see, we see typically about 6 or 7 stars there. We say 6 or 7 because that one can be difficult to spot. So this is a close-up that we're looking at now, taken through a telescope. And one of those stories from the indigenous people of the Americas is from the Nez Perce. And their myth explains that one of the 7 sisters had fallen in love with a human who passed away, and she grieved so much that she pulled the sky over her face like a veil to hide her feelings. And so this is why only 6 of the 7 sisters or stars are easily visible. However, the Pawnee tell that it's 6 brothers who came to rescue their sister, and in turn, she becomes the 7th star of the cluster. The indigenous populations of the Pacific coast tell of 7 sisters who were fed up with their husbands for not sharing their game. And so they desired to be transformed into stars. They got their wish, and the youngest sister's husband accompanied them into the sky, becoming a bull. So I find it interesting to see that different cultures that didn't talk to each other still saw some of the same things in the sky. There's, of course, the Greek myth, which is probably what a lot of us are familiar with. And actually, there's quite a few myths from Greek mythology about the Pleiades. And there are 7 sisters who were the daughters of the Titan Atlas and the companions of Artemis, the goddess of the moon, chastity, and the hunt. Like I said, there's several Greek myths regarding the Pleiades, but almost all include Orion pursuing all 7 sisters at some point, after which Zeus takes them, turns them into doves who fly into the sky, and then become stars that Zeus places on the shoulder of Taurus the bull to protect them from Orion from all of eternity. In Asia, there are also a variety of myths. For example, in India, the stars are known as the star of fire. And they're associated with the fire god and with anger and stubbornness. In Japan, it's also known as Subaru. And that may sound familiar to you. You may be thinking of a car manufacturer right now that has 7 stars for its logo. And that's because that company originally was 5 different companies that merged together. And in Japanese, Subaru means coming together or cluster. In Thailand, there's a beautiful story about how these stars are chick stars, or Dauluk Kai. And in this particular story, one of the stars is a hen, and the rest are her 6 chicks, and they're cared for by a poor elderly couple. However, when a monk arrives at their door and they have no food to share with him, the only option they have is to cook the mother hen. And the hen says goodbye to her chicks and explains that her sacrifice is going to repay the care and kindness of the couple over the years for taking care of them. The chicks, however, decide to join their mother, also sacrificing themselves. And in doing so, they caught the attention of the deity, who was so touched by their love that she turned them into the Pleiades in remembrance. In Oceania, there's also several stories about the Pleiades coming from each of the countries and from the several different cultures and the Aboriginal peoples there within. Usually they're referred to as 7 sisters as well. In the Western Australian desert, they're also fleeing from a man represented by some of the stars and Orion the hunter. In southeastern Australia, however, I really like this particular legend. It says that the stars of the Pleiades, are the glowing coals on the fire sticks of the 7 sisters who first learned how to make fire. There are so many beautiful stories from all over the world about the Pleiades, and particularly when they come from indigenous peoples. I very much recommend seeking out first-person versions of these stories. There's lots of them online, some great research you can do to learn more about those stories. Now, we also have a connection to one more thing with the Pleiades, and that is the Nebra sky disk. And when I say we have a connection, it was discovered here in Germany in the early 2000s. It has quite the history. It's a bronze disk of about the size of a vinyl record, or 30 centimeters in diameter. And if the Bronze Age dating is correct, it is the oldest known concrete documentation of the universe. And if you see, it's clear that's a starry night sky, maybe 2 moons in different phases, perhaps also the sun and the moon. But between the circle and the crescent moon, you see a cluster of stars, and that is believed to be the Pleiades star cluster. So in Germany, we have a tie to the Pleiades as well. Moving on from M45, we're going to look at our next constellation. That's Auriga, the goat herder and charioteer. You can see him here with his whip and his bridle from his chariot, but also on his back he has his goats. The brightest star in Auriga is called Capella, and translated into English, that means little female goat. From there, if you start at the far right ankle, right as we see it, of Orion, go through the middle star of his belt, through the orange star that is his shoulder, Betelgeuse, you can work your way up to a rectangle that is the Gemini twins, Castor and Pollux. And if the names Castor and Pollux sound familiar to you, that's probably because you've read or seen the Hunger Games trilogy. And Castor and Pollux were, of course, in Mockingjay. They were the brothers who were the cameramen. And I like pointing these pop culture references out because I think a lot of the time when we hear the stories of different cultures who looked to the skies and had their myths, we think, okay, those were people who lived a really long time ago and has nothing to do with us anymore. However, that's not true. We still use the stars, the constellations today in our own pop culture. And if you look for it, you can find it in a lot of different movies and books and songs even today. So now that we have these particular constellations out from our wintertime sky, we can look for the winter circle. And it's made of a star in each of the constellations. Starting at our seriously bright star Sirius, we are going to move clockwise to Procyon in Canis Minor. And then we go up through Pollux. Here it also has Castor in there. It's not always used. Then we go to Capella, down to Aldebaran, through Rigel in the angle of Orion, and back to Sirius. I do want to also give you just a little sneak peek at our spring constellations, prepare you for the season that's coming now. Of course, we still have a ways to go. We still are in snowy winter here in the northern hemisphere. But come the middle of March, we will hit that vernal equinox, the first day of spring. So we have that right around the corner to look forward to. And the first thing that we're going to find is another constellation that can really help us through the springtime sky, and that is Ursa Major, the Big Bear. And she has the Big Dipper in her. There we are. And we can use her by using the two front stars of the Big Dipper's bowl to point down to what looks like a backwards question mark. That is a head and a mane of Leo the lion. And if you've ever heard the phrase, March comes in like a lion, that's because of Leo. Leo really starts being able to be seen well above the horizon in the evening sky around the beginning of March. So March comes in like Leo the lion. To find our next constellation, we are going to do some star hopping. So we're going to play connect the dots with the stars to navigate the sky, kind of like we did with Orion. And we are now going to go to the bear's tail, or the handle of the Big Dipper. And we are going to follow the curve it makes. So if you notice that curve, but we're going to call it an arc. And we are going to arc to Arcturus. That is that star there. That is the knee of Bootes the herdsman. He's also known as the bear herdsman, not just cattle. And as he comes out, you will see that he does indeed look like he is herding the bear. We're going to give him a little help. He too has some dogs to help him with his job. And that would be Canis Venatici. Though I'm not sure how much help they might be, they seem really intent on chasing that bear. Finally, once you have arc to Arcturus, don't stop. Speed south to Spica. That blue-white star is the wheat in the arms of Virgo, maiden of the harvest. I'm going to go ahead and make our sky a little easier to see now. And we are at about 4:15 in the morning. But I want to make it easier for you to see the sky without those outlines because I wanted to take a look real quick at the moon. So if you are an early riser and you feel like being out at 4:15 in the morning, you can get a very nice view of the moon. It is currently in the waning crescent phase. We're going to make it a little bigger for you to see, make it a little easier. We're scaling it up by about 20 times. So now you can see that beautiful waning crescent moon. And if you're not sure if the moon is waxing or waning, there is a rhyme that can help you to remember that. So if the white is on the right, the moon is waxing towards bright. So if you see the right side of the moon is illuminated and the shadow is on the left, so the right side is white, then that means it's waxing. It's looking like the moon's getting bigger and fuller. But if the right side of the moon is in shadow, then that means that the moon, therefore, must be waning and appearing to get smaller and dimmer as we head towards a new moon. So the moon is best viewed from about 4:15 in the morning till about 8:30 a.m. So if you don't want to wake up at 4:15, you can wake up a little bit later and still be able to see it out in the sky. It sets around 11:30 a.m. and by then it's going to be pretty difficult to see anyway. All right, well, I don't know about you, but I would like to leave Earth behind now and head out into space. So we are going to leave from Berlin. Well, first we're going to put the moon back to its proper size. And now we are going to leave Berlin behind and head out into space. And you can see Europe here at night, all of the light pollution that we have. It's actually pretty easy to make out the different cities as we zoom out. Do you still know where Berlin is? Have you kept an eye on where we left from? It's all right if you didn't, we can mark that for you. There we are. So that's Berlin. And of course, nearby we have Paris, and down in the boot of Italy, you can see some of the major cities there, like Rome. We can see the Nile River as well. So throughout the different starry nights that I've done during the pandemic, we've visited every planet in the solar system except for one. There's one planet that we have left out, and it's the least visited planet in real life too, not just in our live streams, and that is the first planet, Mercury. So we are going to fly to Mercury with the messenger probe that NASA sent out in 2011. Well, prior to 2011, excuse me, it arrived at Mercury in 2011. The messenger probe was sent to study Mercury, obviously, and MESSENGER stands for Mercury Surface Space Environment Geochemistry and Ranging. However, the messenger god from Roman mythology is also given a nod to here with that name, since it's going to Mercury, and Mercury was the messenger god. But as we know, NASA can't just take a word and use it. Gotta have meaning to each of those letters as well. So it's always fun to see what they do to come up with a way to make sense out of the name for the spacecraft. So MESSENGER, like I said, as we're looking at here now, it orbited Mercury from 2011 to 2015 and successfully completed its mission. And it is the most recent of 2 missions to the planet, the first mission to orbit Mercury as well. The first mission to Mercury was Mariner 10, quite some time ago. But like I said, recently we sent the messenger probe there, and we're actually going to fly to Mercury now. There we go. Over the course of its primary and 2 extended missions, MESSENGER discovered water ice and organic compounds in the permanently shadowed craters on Mercury. It also discovered water in the exosphere and evidence of past volcanism. It studied solar winds and the rate of mass loss from the sun, so the sun's losing mass, and it also performed an Earth flyby, 2 Venus flybys, and a couple Mercury flybys before it went into orbit. And the reason it did this is because it was going very fast. So of course we know spacecraft go fast when they fly through space. You have to escape Earth's gravitational pull to leave orbit. However, Mercury is a special case because it is so close to the sun. The sun's mass it's massive. The sun is very massive. It has most of the mass in our solar system, and it creates the strong gravitational pull that pulls the spacecraft towards it and speeds it up along the way. And so doing the Earth flyby and the 2 Venus flybys and Mercury flybys before going into orbit helped to slow it down so that they could save on fuel, because the more fuel you save, the more time you have at the planet to study it. Mercury is the smallest planet in our solar system. And I know what some of you are saying. We'll discuss Pluto in a little bit. But for now, Mercury is the smallest planet, has been since 2006. Like I said, we'll come back to Pluto in a little bit. Mercury is so small that it is only slightly larger than Earth's moon. Kind of looks like Earth's moon, too. Another way to think about this is if the Earth were a 5-cent piece, Mercury, and that's a 5-cent piece for euro, American cent, Canadian cent, they're all about the same size, then Mercury would be the size of a blueberry or a 1 euro cent piece. Now, Mercury is the closest planet to the sun, but it is not the hottest planet in the solar system. Temperatures can reach a toasty 430 degrees Celsius, which is 800 degrees Fahrenheit, but that's only on the day side of the planet, the side facing the sun. When it is nighttime on Mercury, the temperature can drop to a frigid negative 180 degrees Celsius or negative 290 degrees Fahrenheit. This is due to the fact that Mercury doesn't have an atmosphere to trap in the sun's heat. So another reason that it is so battered and worn, much like our moon, it doesn't have that atmosphere to protect it from micrometeoroids or other objects hitting it. A year on Mercury is the fastest, since it's closest to the sun, it has the smallest orbit, and it only takes 88 Earth days. However, a day on Mercury is 176 Earth days, or 2 Mercurian years. Mercury's axial tilt is also interesting. It's a mere 2 degrees, so it spins almost completely upright. And to give you an idea, Earth's axial tilt is about 23.45 degrees. So what does this mean? It means that Mercury doesn't have seasons like many of the other planets in our solar system do. Even though Mercury is pretty hard to visit, we do have another spacecraft on the way. That is the Bepi-Colombo spacecraft. It is the 3rd probe that will go to Mercury, and it is a joint venture between the European Space Agency and the Japanese Space Agency. Launched in 2018, it completed an Earth flyby last year and is now on the way to 2 Venus flybys and 6 Mercury flybys before entering orbit. One of the big things that it'll be studying is why Mercury seems to be shrinking at its core as its core cools. Now, as I mentioned, Messenger is no longer in use. Its orbit decayed and it crashed into the planet Mercury, possibly creating a crater on the face of Mercury. I would like to fly quickly to Mars now. We're not going to spend too much time at Mars. We've spent a lot of time in previous live streams about Mars, and Mars is going to be getting a little bit more attention later this month. That was also probably the understatement of the year right now there. Mars is going to be getting a ton of attention later in the month because there are 3 rovers and orbiters on the way to Mars right now, and they're all arriving this month. So there's our lovely red planet. The first of those rovers that I'm going to talk about is NASA's Perseverance rover, and it does have tools from ESA on it as well. So this is still an international endeavor. The Curiosity rover will be landing on February 18th, hopefully successfully, and we are going to actually be live streaming that. It's going to be a really fun show. We're going to have some experts. We're going to, of course, be tuned into the live feed from NASA, and we're going to have a chat and enjoy watching this landing of the Curiosity rover, hopefully with all of you. So like I said, that's on February 18th at 8:30 p.m. The next rover that I'd like to talk about, it's also an orbiter, is Tianwen-1, and it will arrive on the 10th, so that's next week. So Perseverance is in 2 weeks, but Tianwen-1 from China is next week. And it has a rover and an orbiter, like I said. It's going into orbit right now. The rover is not going to land for a couple months more. They're going to do some checkouts of the systems, and eventually the rover will land. The 3rd spacecraft is the one from the United Arab Emirates. Unfortunately, we could not find an image of that one, but that will be arriving this month as well. But we are going to continue on. We are now going to fly to the asteroid belt with the spacecraft Dawn. The Dawn spacecraft was a NASA probe with components contributed by Germany, France, Italy, and the Netherlands. So again, another international effort. You're going to notice that a lot of these missions now, they may originate from a country, but it's still an international effort. And it studied 2 of the 3 known protoplanets in the asteroid belt, Vesta and Ceres. So first we are going to fly to Vesta. The mission launched in 2007 and ended successfully in 2018. It was the first time that Vesta and Ceres were visited, and the first time also that a spacecraft orbited a dwarf planet. So like I said, Dawn visited the asteroid Vesta first. And like Neptune, Vesta also has a tie to Germany, as it was discovered in 1807 by Heinrich Wilhelm Matthias Olbers. And he named it after the Roman goddess of home and hearth. While at Vesta, Dawn gathered data showing that Vesta had a metal-rich core and that it may have had transiently flowing liquid water at some point. Data from Vesta is important because it is believed to be the last remaining example of a large planetoid that amalgamated to form what became the rocky planets during the formation of the solar system. So in other words, it's the only remaining rocky protoplanet that we know of that could give us insight into the formation of the Earth and the other 3 rocky inner worlds, Mercury, Venus, and Mars. Dawn orbited Vesta for a little over a year before using special xenon ion engine to leave Vesta's orbit and travel to the dwarf planet Ceres and orbit it. So we're going to travel now to Ceres to check it out. And if you're wondering, how are we not smashing into asteroids in the asteroid belt? And you're thinking of that one scene from a certain movie about wars that happened in stars. Well, that scene with the asteroids in Star Wars was a little bit different from our asteroid belt. The odds, I can tell you, are much better within our asteroid belt. Things are more spaced out than you would think. And of course, we have engineers who are planning every step of the way and mathematicians planning every step of the way to get there safely. So this is the dwarf planet Ceres. Dawn was able to create several maps of Ceres during its time there. And this far surpassed its original planned mapping, so it was able to take extra maps as well, or create extra maps as well. And because it could gather more data, it returned the most accurate results possible. And these images are available to the public on NASA's website. So one of the cool things about NASA, and oftentimes you'll find with ESA as well, is that you can access these images because they are public entities. They're for the public. So Dawn is still at Ceres, even though it's no longer in use because it ran out of propellant in 2018. That's when the mission ended. However, it will continue to orbit the dwarf planet for at least another 20 years. Ceres is naturally an interesting object to observe since it is a spherical dwarf planet within the asteroid belt. Originally, when it was first discovered in 1801, it was classified as a planet. But over the next 50 years or so, more objects were found in the same area, and they were also all classified as planets. And by 1950, it was decided that the objects were falsely classified, and they were all reclassified as asteroids within the asteroid belt, including Ceres. So just remember, as bad as you may feel for Pluto, Ceres went through it first, and for longer. And speaking of Pluto, let's go ahead and start our way to Pluto with the New Horizons spacecraft. So the New Horizons spacecraft launched in 2006, and it's already flown by Pluto now at this point. It takes a pretty long time to get there. It flew by Pluto in 2015, and didn't stop. I mean, it was really a flyby, really quick. On its way there, though, it did carry out some smaller missions. One of the things it did was a flyby of Jupiter. So we're going to do that now. Follow the path that New Horizons took. It didn't just travel to Jupiter and also the 4 Galilean moons of Jupiter, particularly Io. just to take pictures. And we have studied Jupiter a lot, so New Horizons didn't need to do a whole lot of studying of it. However, it was able to get a gravity assist boost to help it reach Pluto more efficiently. Pluto's really far away. It needs all the help it can get to get out there. And since we just did a flyby of Jupiter, we'll continue on like New Horizons did to the dwarf planet Pluto. Now, like I said, New Horizons was launched in January 2006 when Pluto was still the 9th planet of the solar system. However, in August of 2006, after the discovery of other trans-Neptunian objects, which are objects past the orbit of Neptune, or also known as TNOs, these objects were similar in size to Pluto, including the dwarf planet Eris, which is more massive than Pluto. And it was decided by the International Astronomical Union that Pluto fit in better with the characteristics of these dwarf planets, like Eris, who, by the way, is named for the Greek god of discord and strife, which is what happened when Pluto was made a dwarf planet, that's to be sure. And the other dwarf planets that we know of out there, Makemake and Haumea, which have been discovered within the past few years. So why is Pluto not a planet? I mean, we're looking at Pluto right now. It looks an awful lot like a planet to me. Why is it no longer a planet? Why is it a dwarf planet? It is a planet has to be in orbit around the sun and not a moon. So check, Pluto does that. It has sufficient mass to be nearly spherical in shape. Pluto looks like a sphere to me. A planet can clear its neighborhood. In other words, it dominates its orbit. And it's here that Pluto fails the test to be a planet, as Pluto, like the other 4 recognized dwarf planets, cannot clear its own orbit, and so therefore it cannot be a planet. It orbits with all the other TNOs in the Kuiper belt, just like Ceres does with the asteroids in the asteroid belt. However, all of the TNO dwarf planets are now classified further as Plutoids, recognizing how important Pluto has been in our history. Now, I would finally like to add that none of these planets, dwarf planets, planetoids, asteroids, etc., are sentient. They have no feelings, so please don't feel bad for them because they don't feel bad for themselves. They don't feel anything. So you can instead be happy to know that science has helped us to better understand our solar system, and that's why Pluto was reclassified. Okay, so now that we have that out of the way, we are at Pluto. We're actually looking at an image from New Horizons right now. This is one of the first images that came back from New Horizons in 2015, and it is the famous image of Pluto's heart. So some of the geological features on Pluto have seemed to create a heart on its surface, which everybody, of course, immediately fell in love with. Makes a great Valentine to give someone, by the way, the image of Pluto's heart. Just going to throw that out there. The 14th's coming up. Now, like I said, New Horizons arrived in 2015 and immediately began sending the data back to Earth, but the majority of the images were released a year later to the public, surely due to the volume and size of what was being sent back. And Pluto, obviously very far away, so a day on Pluto is 153 hours long, but a year is 248 Earth years. So we have not seen Pluto experience a full year, Pluto year, since it was discovered. Now, you can actually do an experiment regarding the day on Pluto, and that is that you can see what the sun would look like, or what the lighting situation would look like on Pluto at high noon. So right in the middle of the day on Pluto. If you go outside here in Berlin at about 5:05 p.m., the way the light is then is what noon looks like on Pluto. If we go back to our analogy of Earth being a 5-cent piece, then Pluto would be the size of a popcorn kernel. And it has an axis of rotation that is 57 degrees with respect to its orbital plane. So that means it's like Uranus in that it seems to rotate on its side. It's also like Venus and Uranus in that it has a retrograde rotation, which means that it spins from east to west instead of west to east like Earth and the other planets do. Pluto is an icy, rocky world with fairly low density, and its temperature can range to about 226 degrees Fahrenheit to Celsius to 240 degrees Celsius. And in Fahrenheit, that's negative 375 to negative 400 degrees. So that's pretty cold. And we're going to look at another one of New Horizons images now to take a look at some of the geological features up close. So Pluto has mountains that are just blocks of water ice that are coated in frozen gases like methane. There's also evidence that Pluto has tectonic forces that are slowly changing its surface. So we see this now, but a really long time into the future, we may see that it looks completely different in that same area. New Horizons study Pluto's atmosphere and its effects on the solar wind. And I absolutely love this image. This is another New Horizons image that it took. And the image you're seeing, that is Pluto's atmosphere. That blue glow is Pluto's atmosphere. So the atmosphere is mostly made of molecular nitrogen, and it's very, very thin. And when Pluto comes closer to the sun in its orbit, the surface ice sublimates, which is when a solid goes directly to being a gas, skipping the liquid phase, and it creates a temporary atmosphere. So when Pluto moves away from the sun, the dwarf planet becomes much colder, which then causes the atmosphere to collapse. And it's believed that the atmosphere may freeze and snow back down onto Pluto. And of course, this cycle repeats as Pluto goes through its orbit. New Horizons was also able to get close enough to map both Pluto and its largest moon, Charon, entirely. So Charon also can be pronounced Charon or Chiron, depending on who you talk to. However, the discoverer of Charon, James Christie, even though it's spelled Charon, so you would think it would be Charon, he wanted to pronounce it Charon because his wife's name was Sharon. So he tied that little bit in there, even though it had to be named for something to do with Pluto, who in Latin mythology is or Roman mythology is the lord of the underworld. And Charon is the ferryman for the underworld. It's Pluto's largest moon at half the size of Pluto, and it also orbits 20 times closer to Pluto than our moon does to the Earth. What's really interesting about this, and we're looking at Charon right now closer up, what's interesting about the way that Charon orbits Pluto is that it puts the barycenter outside of both Pluto and Charon. And the barycenter deals with the center of mass, which for a practical example would be if you tried to balance a ruler on your finger, the point where you could balance it without it falling is the center of mass or the center of gravity. And in space, if at least two objects are orbiting each other, they too will have a center of mass, which will be the point where the objects orbit each other. This is the barycenter. So for the Earth and our moon, for example, the barycenter lies within the Earth, as Earth is much more massive than our moon. But with Pluto and Charon, however, the barycenter lies outside both Pluto and Charon, since they are closer in mass to each other. And so they actually seem to orbit each other more than Charon orbiting Pluto. Charon's also tidally locked to Pluto. It's mutually tidally locked. So that means that Pluto only ever sees one side of Charon, and Charon only ever sees one side of Pluto. The Earth and the moon are also tidally locked, but not mutually. So we always see the same side of the moon, but the moon sees all of the Earth at some point. Pluto does have 4 other moons that New Horizons was able to image to varying degrees of resolution due to its flight path. They are all named for monsters or elements coming from the underworld. This is one of the rules that applies to Pluto. Anything that is discovered around it or with it must pertain to Pluto and the underworld. That is a rule from the International Astronomical Union. These moons are also much smaller than Charon and Pluto. They're irregularly shaped. They're not tidally locked to Pluto. And it's believed that these moons coalesced from debris after a massive collision between Pluto and another object during Pluto's formation, kind of similar to the Earth-Moon system's giant impact theory. And these 4 smaller moons also orbit Pluto and Charon. So it's not like when you look at, for example, the orbits of Mars's 2 moons, where each one has its own orbit just around Mars. It's different in that you see all of them orbiting both of those 2 moons. It's interesting to look at, and part of that is due to the Berry Center being outside and kind of changing the way that Pluto and Charon orbit compared to a planet and its moon. So the 4 smaller moons, let's begin with Nix, and I will bring up an image here for you to take a look at those so you can see the images from New Horizons. Those are the best images we have. Some of them are a little blurry because New Horizons simply just didn't get close enough in its flight path. Nix was discovered at the same time as Hydra, so they were both discovered in 2005 by the Hubble Space, or with the Hubble Space Telescope. And Nix is named after the Greek goddess of darkness and night, and is also the mother of Charon, or Charon. Hydra is named for the 9-headed serpent from Greek mythology, and this is on purpose. This is to specifically give a nod to Pluto for formerly being the 9th planet. It's the 2nd largest moon of Pluto, and it's the farthest away from Pluto. It was discovered at the same time as Nix, like I said, with the Hubble Space Telescope. And I point that out again because it was also on purpose that it was given a name with H as a nod to the Hubble Space Telescope. And it was presented with Nix coming first so that the initials of both of the moons were N and H, giving a nod to New Horizons. So astronomers really like having these ties to the objects that they find and the tools that they use. Kerberos was discovered in 2011, so more recently, and it was discovered with data from New Horizons while it was on its way to Pluto. And it has a double lobe shape, which suggests that 2 smaller objects merged together at some point in its history to create the moon. And Cerberus is a 3-headed dog that guards the underworld in Roman mythology, and it's pronounced Kerberos here, and spelled with a K just because there was also an asteroid already named Cerberus, so they gave it the Greek version of the name instead. And finally, we have Styx, discovered in 2012, also with the Hubble Space Telescope, and it is the smallest moon of Pluto, but has the closest orbit, and aside from Charon, of course. And Styx is the goddess of the river Styx that the dead have to cross in the underworld. And yes, of course, also it's the name of a rock band, and every time I hear it, I get Come Sail Away stuck in my head. So you may be wondering, now that we're this far out, what is New Horizons up to? And are there other spacecraft out this far? Are they still working? What's going on with those? Those are great questions. And there are other spacecraft out there. New Horizons is not the other one, and they are still working, and that's the Voyager spacecrafts. So Voyager 1 and Voyager 2, they were sent quite a while ago, and you can see slowly where they're located. They're really far outside of the main part of our solar system now, still within for a little bit, but getting close. They are still functioning and communicating with Earth. Of course, it gets harder and harder to do, but that's thanks to the Deep Space Network. And Voyager 1 is the spacecraft furthest from the sun right now, and will continue to be. New Horizons, being the baby of the family, is only about 1/3 as far away from the sun as Voyager 1. So the next question would probably in your minds be, will New Horizons pass Voyager 1? Or Voyager 2 for that matter? No. New Horizons is not going to overtake the Voyager spacecraft. It isn't traveling fast enough to catch up with them. It's also on a different trajectory, as you can see here. Where are the 3 located now? Like I said, they're still in the solar system. New Horizons is still in the Kuiper Belt and will be there for some time as it explores the TNOs there. And its mission was renewed through this year. We'll see if it gets renewed again, but it's still sending back valuable data. Voyager 1 reached interstellar space in 2012, which means that it's past the heliosheath, which is the boundary of our protective solar bubble and the protective magnetic fields created by the sun. Voyager 2 reached interstellar space in 2018, so much more recently. Where are they going and when will they arrive? Which will get there first? That is a good question too. Voyager 1 is slated to pass within 1.7 light years of the star AC plus 793888, super catchy name, in the constellation of Ursa Minor in the year 40,272 AD. So a little more than 38,000 years from now. So I probably am not going to get to see that happen. Voyager 2 is slated to pass within 1.7 light years of the star Ross 248, and that is in the constellation of Andromeda. About 40,000 years from now is when that will happen. And as for New Horizons, like I said, its mission was extended, so it's hanging out in the Kuiper Belt for now. Where it gets sent after it has explored everything that we want to explore in the Kuiper Belt will depend on a lot of different factors. Hopefully we'll be hearing a lot more about it this year. At this point, we're going to go ahead and fly back to Earth. I'm not going to leave you stranded at the outskirts of our solar system. And as we come back to Earth, the beautiful blue marble that we can see, as the Apollo 17 astronauts put it, we see day and night, we see no borders, we just see where we all live together. The theme this year that we are celebrating at the Stiftung Planetarium Berlin is We Are Not Alone. And we truly are not alone on the planet Earth, especially this year. And last year, for that matter. And we have to continue taking care of each other, taking care of our planet, of course. There is no planet B. But we need to continue taking care of each other as well, looking out for each other. Keep hanging in there as we work towards some normalcy, of course. And I would like to thank you all very much for joining us this evening. That is one of the wonderful things, the silver linings of the pandemic, is that I am grateful that you all welcome me into your homes during these Starry Night presentations. I hope that you are enjoying yourselves and having as much fun as my colleagues and I here are, and I want to thank my colleagues as well for all of the technical help that they've been giving me and support during the course of the evening, so big thank you to them. I want to remind you all that we do have on February 18th, we do have the Mars landing live stream again at 8:30 p.m. So that's going to be a lot of fun. Definitely join us for that. We also have regular live streams, normally in German. And next Wednesday, we'll be having one about spacecraft, and we will also be having our astronomy updates. So the one about spacecraft, our All at Home series, will be on Wednesday, and the astronomy update will be on Friday. So good way to practice your German if you're not a native German speaker. Like I said, come join us for that. And with that, I would like to thank you all so much for joining us today. And please, like I said, take care of yourselves, stay safe, stay healthy, and join us again for our next live stream.